All right, CNT125, we're on our little module here on voice over IP. Now we'll get into some of the terms and equipment and so forth for specifically IP phone. Analog telephones, that was your traditional analog phone. There's different ways to have them connect into a digital phone network. Your ATA, your gateway device, or digital IP PBX would do that. So we'll take a quick peek at those. IP telephones, these are what are commonly used now. These are actually going to packetize the voice for you and literally send packets across the network. And then a soft phone, which a lot of us actually already use now. If you have a Zoom phone kind of thing, that is a soft phone. This is a piece of computer programming application, if you will, that's programmed to act like an IP phone. So actually communicate with the IP phone server, if you will. So let's take a peek. Here's your traditional phones, IP phone, soft phone. Here's your traditional analog phone, IP phone like so, soft phone like so, just to kind of get those sorted. Now, we'll come back to those and add in a couple more details. Let's get out the terminology codec. Codec is coder decoder. Codec is coder decoder. My voice is analog, okay, and for it to go across a digital network, I need that to be coded from analog into digital. So codecs are going to get used to do that. There are two common codecs that we encounter with IP phone, G711 and G729. We're just going to mention these for familiarity. As we work with our IP phones in the lab room, I'll have you look for this to see what is the system running. So G711, this is an ITU-T standard. Hopefully you remember, ITU-T is a subgroup of the UN. Okay, this is an ITU-T standard for IP telephony, released in 1972, and this is what's called pulse code modulation. It is straight analog to digital conversion. What it does is, as you see here, would be my representation of my voice, the frequency of my voice that's talking. What it does is it plots where this would be on a graph many times a second and sends those plot points as a 8-bit number. The other end receives that 8-bit number and starts replotting it and connecting all the dots to reproduce the wavelength, the waveform, my voice, if you will. And it's roughly this. Our human speech is roughly 0 to 4,000 hertz frequency. So a long time ago, they figured out to do this accurately, you do twice that, 8,000 samples per second then. Twice your frequency range you're trying to sample, you do samples twice that. So 8,000 samples per second, so 8,000 of these per second, and you can represent this frequency band well. So 8,000 times per second you're doing the little plotting, and I use an 8-bit number for each one of those, and that's where your 64K comes from. Your original phone line was a 64K bandwidth, if you will. Which 64K back in the days of dial-up modems that were using 30 or 28.8, that's a significant bandwidth. 28K in those days for dial-up modem. Your phone line was 64K. That was significant bandwidth. Your G711 is using just straight pulse code modulation, so it's a 64K signal, which by today's standards is not much of anything. One of the other codecs you run into is a G729. G729, you actually, in many cases, need to get a license or pay a royalty fee to use this. This is going to do a slight bit of compression. It's going to do coding of speech at 8 kilobits per second using code-excited linear prediction speech coding. It's using less bits per time, and it's actually doing kind of prediction of like, okay, you keep going up, so the next one's going to go up. We're going to skip that, and then we'll sample the next one. Then we'll skip that, and we'll sample the next one. And it's a way to use less bits per time to represent the same voice signal. And initially, this was you use less bandwidth, but the voice quality, I'm going to exaggerate here, the voice quality might have been like this, where it's like a little bit muffled. But in those days, to save the bandwidth, that was worth it. So G729 you might run into. So recognize the G711 and G729. When we do IP phone in the lab room, we're going to do some Wireshark, and we're going to be looking to see what codec is it using. So just be recognizing those G dot numbers, okay? All right, so if I have analog telephones, I can still connect them into my IP phone network. And actually, I have Verizon Fios at my house, so that is a digital connection coming to my house, fiber optic. I still have an analog phone in the house, and that connects into an ATA. It's built into the Fios equipment, but that analog phone line connects into that ATA to convert that to a digital signal to go across the Fios connection. And that analog telephone adapter sometimes is built into things. You can actually buy an actual adapter to do it. Okay, this would actually be an ATM adapter right there, or it can be built into things like a voice over IP router or gateway. Many times this is what you have, and this is kind of what I have at our place, built into the Verizon Fios box, if you will. The other way you could handle your analog phone line is actually connect the analog phone into an IP PBX. An IP PBX, I can get phone cards that I can plug my analog phone line into. So here's just 4 ports. Here would actually handle a whole 66 block of phone lines. So if you still had the old phone lines come into a 66 block, I could get this card, snap it in there, and connect my 66 block into this. And I could take my existing analog phone structure and support it with my IP PBX. That's what I could do. Now, IP PBX, this is basically your phone server. This can be done a couple different ways now. Initially, it was done as on-premise, meaning I had to have my own phone server, my own IP PBX, to handle the receiving of the phone calls and routing them to the correct phone or routing them outside to another site. And things like Cisco Call Manager, which you can still get and put in, is just that. It is a IP PBX that Cisco has for managing phone calls and so forth. And it would be an on-premise IP PBX that you can put in. I can buy other appliances. These are some other ones that are out there. These are usually a hardware appliance that has a Linux-based phone server on. Asterisk. It's a Linux-based phone server, usually Asterisk, that has hardware around it to make it all work. Here would even be one. This is on-premise IPPBX from Fortinet. Fortinet has their own FortiVoice enterprise phone system to, again, gather your phone calls, etc., etc. So this would be an on-premise solution. Well, we can't not think about Chapter 7, cloud computing, blah, blah, blah. You can have a hosted IPPBX as well. I can have a hosting service that it has the server for me. All I need to do is point my phone calls to them, and in the server, if you will, once I get in accounts, log in and plug in Doug Brown. Doug Brown is a user, here's his phone number. Sally Smith is a user, here's her phone number, etc., etc. And they would host the server for me. All I need to do is maintain the account. So here's a couple options. Here would be an example of pricing for Zoom phone. $15, $20 a line. Which, again, they're maintaining the server and everything for me. All I'm doing is putting the users in and maintaining those accounts. And then here would be another Vonage to give you an idea. They're looking at like $14, $15 a line kind of thing. And again, I could have a desktop phone point to it. I can even have a soft phone point to it. If I have IP phones in my network like so, and I have a picture of this guy in here because he's kind of a workhorse. We actually have a bunch of those in the lab room, and those are very common IP phones in workplaces. Well, the IP phone itself is designed to plug into the network and be a node on the network. So this thing is actually going to convert my voice into packetized data, and when it plugs in the network, it's actually using a regular network port to plug into the network. You'll notice that there's actually 2 on here. Some phones actually have 2 ports that one will plug into the switch, and your desktop PC that it would be in an office plugs into it. So you would have this kind of arrangement. The phone plugs into the wall, the PC plugs into the phone. Prior to that, you would have to use 2 outlet jacks on the wall, which cabling people, you start understanding the cost of putting an outlet jack in. So this phone being able to handle both reduces that overall cost. As we do our phone config, we will configure the switch to recognize that both are here, and we're actually going to put the phone data in one VLAN and the PC data in a different VLAN. Okay, just to kind of give you a heads up on that one. So I have this kind of connection going on. IP phones have all kinds of features, and we're kind of used to that with our smartphones now, all kinds of features that we have with being able to call. So lots of things that IP phones brought on the scene for us. But we do need to worry about your conventional analog phone got power from the CO, from the local loop. It actually powered the phone for you. That was super handy in the 1930s and 40s and 50s, where you might not actually have electrical power at your house. The CO would power, your central office would power the phone for you. So whether I had electricity in my house or not, my phone could still function and work. Well, my IP phone needs power as well. Well, one way I could do it is a power cord. I plug a power cord into the phone. That is one way to do it. It's not ideal, but it is one way to do it. In the lab room, we're going to do that because our switches don't have power over Ethernet. The downside in business is, I always joke, the downside in business is people like to move their offices around, and when they do, guaranteed they're going to forget to plug their phone in. That is one downside. The second downside, more importantly, if the building power goes out, this phone goes out. So what typically gets done is in an environment like this, you actually power your phone from the switch using power over Ethernet. And power over Ethernet, here's standards for it over the years. Okay, IEEE 802.A, F, AT, BT, so forth. Okay, your switch actually powers that device. Now, hopefully you remember that from back in 120. Your switch can power things like phones, IP cameras, access points, etc. And that allows us to put the device where we need it, not where it happens to be near a power outlet. Really important, really helpful. As long as I buy my switch that's capable of doing power over Ethernet, we're golden. So when I pick out switches, I picked out, this is a relatively modern Cisco model number, C9200 power over Ethernet switch. As long as I pick the right model number, here is its power over Ethernet capability. Other lower models on the list might not be capable. So I need to make sure I'm buying one that's capable, and you'll notice that it has a wattage rating. Yes, any device I'm going to plug into it is going to use a certain amount of wattage. Here would be phones. These phones that I picked out, and again, these are modern Cisco phones, are only going to consume about 4 watts, if you will. So they're not going to use a whole lot. But if I go to like access points, I might be using 30 some watts per access point. So as I buy my device, I need to make sure, will it handle 10 of these and 10 of those kind of thing? Will it handle 10 or 20 IP phones? Will it handle 5 or 6 access points? So I add those numbers up to make sure that this will suffice. And most of these switches work when they get to that wattage limit, they just stop powering the devices you plug in. For basically protecting the switch so it doesn't burn itself up. So when I pick out my switches, I need to look at that wattage rating, and you can probably figure this is more expensive than one that doesn't have power Ethernet, and this is more expensive than this one right here. Yes. So I would need to do my homework and make sure I'm getting enough wattage for my switch based on what I'm going to plug into, and I can look up what it's going to use to know how much do I need. So I can do that straight from my switch. If my switch does not have the capability, I can actually buy power injectors that will allow me to, here's my non-power Ethernet switch. I can run power from here to the ejector, data into here, power and data across here, split it back off to power the camera and data. I can use a power injector to get the power to my device. Again, here would be another way to do it as well. We did that for one of our early access points in our church. We used a little power injector to get power out to the access point that we put out here. All right, we come back. We'll do one last section, I believe, on our equipment for voice over IP.